Now, I will explain an important application problem to you, which is about income distribution and related with the area between the curves. The United States Census Bureau compiles and analyzes a great deal of data having to do with the distribution of income among families in the United States. For 2014, the Bureau reported that the lowest 20% of families receive 3% of all family income. Okay, so just the lowest 20. Okay, let's show that this part. This is the highest. This is the lowest. So this is 20%. The lowest 20% of the family received the 3% of the all family income. Okay, so they receive 3% of income, of all income. This is not a good situation actually, because 90-70% of the other income received by the 80% people. Actually, if you look the top of the 20% people, you will see very worst situation. This is the top of the 20% people. Okay, these are received the 51%, okay, of the total income. So the 60% of these people takes the 45% of the total income. Okay. We can make the table. Okay, actually, in your textbook there is a table. This explains this situation about the family income distribution in the United States for the year 2014. Okay, so income level is under $21,000. The number of the people, okay, x the number of the percentage of the people, 0.20. So this is 20% of the all people, and the y represent the income. So this is 3% of the total income. Okay, so this is number of the people, or percentage of number of the people of family, let's say. This is income. So x variable represents the percentage of the family. Y variable represents the percentage of the family of the all family incomes. Okay, so let's continue to complete our graph. So if the income under the $41,000, it includes these peoples also. So this is 40%, and they takes the 0.11 or 11% of the total income. If the income level under $68,000, okay, the number of the family is 60% in this situation, and their total income is 0.26, so 26%. If the income under $112,000, the people is 0.80, so 80%. The total income, or they received the 49 from the total income. So this data can be sketched the graph by using the point-by-point graphing. So let's say this point is 1%. This is the x-axis. This is the y-axis. So when this is 0.2, 0.4, 0.60, 0.18. Okay. So at that level, this is 0.3. This is 3%. 0.03. Here, this is 0.11. 0.11. Here, this is 0.26. 0.26. And when this is 18, 0.49. I hope my scaling is good. 0.49. So one somewhere here. So the graph of this income distribution like this one. When for the 1%, of course, all income received, so it have to be 1. Okay, this is the graph of the distribution of the United States family income in 2014. Okay, actually this curve is known as a Lorenz curve. Okay, so the function f of x is generally found by using the regression analysis, which is a technique for fitting the function to a data set over a given interval, as you know. So from this data set, we obtained this Lorenz curve. The variable x represents the cumulative percentage of the family at or below a given income level. Okay, here. And y represents the cumulative percentage of total family income received. So for example, the data is 0.40.011, so this data, this point. This point is 0.14.0.11. Indicates that the bottom 40% of family received, actually this 40% of family incomes under $41,000 received 11% of the total income for all families in 2014. Okay, so this is Lorenz curve. It is called the Lorenz curve, this f of x function graph. Actually, this is y equals f of x function, which is obtained by using this data, okay, using regression analysis. So when the total income distributed equally, if this situation occurs, okay, so always this is y equals x line. What does it mean? This means the 20% of the people takes the 20% of the income. 40% of the people, my scheduling is not good. Okay, so it should be under the somewhere. Let's say this is 26. Okay, this is our point. So that point is 0.4, etc. Maybe this is also not good point, not good selection. 0.19 somewhere here. 0.49. Okay, so this is the 18. Okay, so this curve is the equal distribution. Okay, so absolute equality of income would occur if the area between the curves and y equals x, so this is y equals x, were 0. Okay, so if this area is 0, this means Lorentz curve equals y equals x, or f of x equals x function. So we have equivalent distribution. Okay, in this case the Lorentz curve would be y equals x, and all families would receive equal share of the total income. That is, 5% of the family would receive the 5% of income, 20% of family would receive the 20% of income, 65% of the family would receive 65% of income, etc. The maximum possible area between the Lorentz curve y equals x and y equals x is 1/2. How is it possible? If like this, let's show that. This is exceptional, very exceptional situation. But if one people has the all income, nobody takes the money 0, 0, 0, 0, and this one people takes the that money. Okay, so this is that means one people receive the all total money, total income. So in that situation, what is this area? This area is, this unit is 1, this unit is 1, 1/2 times 1 times 1, so this is 1/2. Okay, so I would like to repeat, the maximum possible area between the Lorentz curve and y equals x is 1/2. The area of the triangle below y equals x, this triangle. Okay, in this case we would have absolute inequality. This is inequality. Okay, what that means, all the income would be in the hands of one family, and the rest of the family would have none. In actuality, Lorentz curve lie between these two extremes. It is not possible. Okay, the situation, and between these two extremes, not the y equals x and not this one, is not possible. But as the sheet area increases, the greatest is the inequality of income distribution. So this area should be a small number. When it is close to the 0, it is fair. Okay, we use single number, the Gini index, named after Italian socialist Corrado Gini. We use the Gini index to measure income concentration. The Gini index is the ratio of two area, the area between y equals x and the Lorentz curve, and the area between y equals x and the x-axis, this one, 1/2. Okay, so Gini index is the ratio of the area between the y equals x and the Lorentz curve. So what is this area? From 0 to 1, x minus f of x dx over the area between the y equals x and the x-axis. So this is 1/2. So over 1/2. So as a result, the Gini index is 2 times from 0 to 1 x minus f of x dx. This is called the Gini index. Clearly you can observe this area between the 0 and the 1/2. So here we multiply 2. So Gini index between the 0 and the 1. Okay, so this is very important. Gini index changed the value between 0 and 1. 0 case is very when Gini index is 0, there is absolute equality. Okay, all people share equally in the income, actually this is very good situation, but never we can see. When a Gini index is 1, it means there are absolute inequality. One family has all income, okay? The rest of the families have nothing. So these are very exceptional situations, 0 and 1 case of origin index. So generally it is between the 0 and the 1. So we can make some comment about the Gini index. The closer the index is to 0, the closer the income is to being equally distributed. This is good situation. The closer the index is to 1, the closer the income is to being concentrated in a few hands. This is bad situation. Generally, like the Turkey, which underdeveloped country, the Gini index is bigger than the 1/2. It's close to the 1. So if in the developed country, general Gini index is 0.2, 0.3, etc. Okay, so it is close to the 0, but of course it is not possible to be 0. The Gini index of income concentration is used to compare income distribution at various points in time between different groups of people, before and after taxes are paid, between the different countries, etc. Okay, so by the Gini index you can compare. Okay, let's look example